Number 5, we have hypochlorous acid. And the first thing we must do is write out a chemical equation for the dissociation. It's a weak acid, so we need to put double-sided arrows. Again, add it to water. And that's our dissociation. So the next part of the question is saying, calculate the pH of a solution that contains 1 molar HOCl and 1 molar OCl minus. We can use Ka again, and we have Ka up here, to put in our proper ratio of our acid and conjugate base. So we've got 3.5 times 10 to the minus 8 equals X. That's our concentration of H plus that we are looking for. And 1 and 1. And we can see at this point that they cancel, and our pH is equal to the negative log of our Ka value, which is also known as the pKa. And we end up with a pH of 7.45. The last problem is saying calculate the pH of a solution that contains 1 molar hypochlorous acid without any added OCl minus. So for this, we're going to have 2 X's here. So again, this is our Ka expression. And we're saying at equilibrium, what are all these species making? At equilibrium, what's happening? So we put in hypochlorous acid, what shakes out after the equilibrium? And so we can look at our chemical reaction. We start with 1 molar here. And when it dissociates, it's going to make the same amount of our conjugate base and of our H+. It's going to make the same amount of each. So we're going to put in 2 X's in this equation. Because they should be the same. And we'll assume that the change to our acid is negligible, so we'll make that 1. And from here, you can solve using x squared. Take the square root, and we get an H plus concentration, 1.9 times 10 to the minus 4. And if we take the negative log of this number, we get a pH 3.7.